In this video, I will explain conservation of momentum in 2 dimensions. Let us revise conservation of momentum in 1 dimension. For 2 objects of masses m1 and m2 moving with initial speeds u1 and u2 respectively when they collide or when one of the objects explodes, then if after collision or explosion they move with speeds v1 and v2, then their total initial momentum will be equal to total final momentum. That is the conservation of momentum. Now we have applied this concept to collision of objects where they either stick together or one object is stationary or both are moving, or after collision one object stops and the other keeps moving, or they both are moving, and so on. All those examples are covered in my another video. You can have a look at it. I'll drop the link here. Now, conservation of momentum in 2 dimensions. So if you consider 2 objects both having mass m, the first object collides with the second one at an angle. As a result, they move in the xy plane. So if you consider the xy plane here along the x-axis where the objects were initially situated, and then the motion in the xy plane. So the first object was moving with speed u. After collision, here we have speeds v1 and v2, and they make an angle theta and alpha respectively with the x-axis. Now since momentum is always conserved, we will consider momentum conservation before and after in x-axis and then y-axis. Therefore, along x-axis, before momentum was mu, after momentum is mv1 cos theta, the component of v1 along x-axis, and mv2 cos alpha, the component of v2 along x-axis. Along y-axis, since there was no motion along y-axis, the total initial momentum along y-axis is 0, and that will be equal to mv1 sin theta, the sine component, along the positive y-axis minus mv2 sin alpha. So we use the negative sign because the v2 component is along the negative y-axis. Now the solution part is easy. Now since we have 2 equations, some of the variables will be known. So we substitute and simplify for 2 equations. Let us solve this further using an example. An arrow of mass 160 gram moving at 34 meter per second hits a moving target of mass 300 gram moving at 5 meter per second and gets stuck to it, as shown in the figure. Calculate the final direction and angle of the system after collision. So before we have here u1, u2, their masses m1 and m2, and we have the initial angle given for the arrow. Now after, we can visualize that since the arrow gets stuck into the target, they move together with speed v, and it makes an angle theta with the x-axis. Let us label the masses 0.16 kg. So 160 grams converted to kilograms. Same for 300 grams, we convert to 0.3 kilogram. We assume the x and y plane here. Now after collision, the total combined mass will be 0.46 kg since they stick together. And let us imagine the axis here. Now since this is in 2 dimensions, we will write 2 separate equations for x-axis and y-axis. So along x-axis here, the object m1 is moving at 34 meter per second with an angle of 40 degree, and the target of 300 grams is moving along the negative x-axis with speed 5 meter per second. So we have m1 u1 cos phi plus m2 u2 equals to, now after, since they stick together, we write m1 plus m2 and final speed v moving with an angle theta with the x-axis, so cos theta. Substituting the values, now here we take the negative sign because the target was moving towards left, that is along the negative x-axis. Now for along y-axis, initially only the arrow is moving along the y-axis, so the sine component of 34 meter per second, so m1 u1 sin phi, and together here we will have m1 plus m2 v sin theta. We substitute the values and simplify it. We get equation 1 here. Along x-axis, if we simplify, we get this equation. If we divide equation 1 by equation 2, we get tan theta equals to 1.31 or theta equals to 53.68 degrees. And by substituting this value in either equation 1 or 2, we can find the value of V as 9.42 meter per second. This numerical feels really difficult at first, but if you know how to split into components and you take proper directions, like here we have to take the component, but for the second object we didn't need a component. Here we had to take the cosine component. So the physics part is limited to you taking along x-axis and y-axis the first two set of equations. The rest is just mathematical simplification where you solve for two variables and you have two equations. So you substitute, simplify or divide, multiply equations, find one value and then substitute it in either of the equations to find the second variable. Now we try this example. A 1325 kilogram car moving north at 27 meter per second collides with a 2165 kilogram truck moving east at 17 meter per second. They stick together. In what direction and with what speed do they move off after collision? Imagine this. The car is moving towards north. The truck is moving towards east. And after collision, they will move over here. So apply the same concepts here. It will be easier because the car was only moving in one dimension. You don't have to take x and y separate components. Here the same thing you can apply along x-axis, along y-axis. And then after, since they stick together, m1 plus m2. Try to solve and simplify. I'll give you some choices. And let me know in the comments below. Don't forget to like, comment, share and subscribe to my channel.